Today is October 2nd, and we're going on to section 2.5. Yesterday we did section 2.4, which was multiplying numbers. Again, mainly working with positives and negatives and some rules for what's going to happen, what am I going to get for an answer if I multiply two positives or two negatives or one of each. We're moving on to section 2.5 now. Apply the distributive property, but we're not actually going to talk about the distributive property today. First, we're going to work on some terminology and some other words that I need us to know so that we can, when I say them in class, you know what I'm talking about, or when you see them in the book or on a test. So that's kind of what we're going to talk about today, some words we need to know, and also something we can do with expressions to simplify them too. At the top here you can see we've worked with expressions, so we know expressions like this, like 3x plus 5 or 9y squared minus 7x or plus 6. So we work with those kind of expressions. Again, remember, an expression won't have an equal sign. It's something we can't solve. Okay, we can evaluate or simplify it, but we can't solve. We can't actually find out what those variables are unless they tell us. An expression we can evaluate or simplify a little bit, and that's what we'll do today. There are some names, some words that we need to know about the things that are in an expression. And here's a few of them right here that I want us to know. Terms, coefficient, and constant. Each of these words you'll hear me say in class sometimes, or you'll see in the book, so I need us to know what those things are. Terms, that definition says that terms are the parts of an expression that are added together. In this expression that I have up here as an example, 7x minus 4x plus 10 minus 3y, the terms are just each of the individual things that are added or subtracted together in this problem. So like 7x, this right here is a term. So I could say, one of the examples, there's a term for me. Also, 4x is a term, but notice that there's a minus sign in front of the 4x. What that does is essentially when I list this as one of my terms, I'm going to say that it's negative 4x. Okay, that subtraction sign tells me that if I was dealing with that term, I would have to subtract it from another term. Or another way you can kind of see that it's negative is if I chop dash, like we did in a couple sections ago. When I'm subtracting something, I can chop dash it. I can think of it like plus negative 4x. That also works too. So I have to think of that because there's a subtraction sign in front of it. I need to think of that as negative 4x. 10 will also be a term. And then even this last one, again, same kind of thing. It's negative 3y. When there's a subtraction sign in front of it, I need to think that I would subtract that term from something. So it's almost like making a negative. Or again, I can chop dash and think of it like negative 3y. So those would be my terms. There are 4 terms in this expression. Going on to the next one, the coefficients. Coefficients of an expression. Coefficients are the number part of a term with a variable. So we're only looking at the terms that have a variable with them. So if I'm looking at my variables that have a number, I would say 7x, I'd say negative 4x, and I'd say negative 3y. Well, the coefficients I'm talking about, though, are just the number part right in front of the variable. So my coefficient for one of them could be 7. Okay, that's a coefficient in this expression because it's the number in front of that letter x there, okay, that variable. Also, another coefficient will be, again, negative 4. This term is negative 4x. So when I talk about the coefficient that sign comes along with it too. It's negative 4. And this last one also negative 3. The coefficient of that term will be negative 3. So coefficient, the number part of a term with a variable. So just the number we're talking about. And constant. The last one on this page, a constant is the number in an expression that does not have a variable part. And there's only one of them in this particular problem. So right here, the 10. That has no variable part to it, so that is my one constant that's in this problem. Terms, coefficient, constant, those words you'll hear me say in class, you'll see them in the book. Some problems today will ask you to identify these parts of the expression. And so we need to know what these mean. One more definition we need to know for today is the definition of like terms. We talked about terms on the previous page. So remember the terms in an expression, like this example below again. The terms in this particular expression are 7x, negative 4x, 10, and negative 3y. Those are all terms. Like terms are terms that have the exact same variable part. So in this case, there are 2 like terms in this particular expression. Okay, there's 7x, this is a like term, and 4x. Those both have x as the variable part of that term, so they are like terms. When I have like terms in an expression, I can actually simplify it and combine those in the expression. All I do is I take the coefficients of those like terms and add or subtract them as the problem tells me to. So in this case, this says 7x minus 4x. If I subtract those, subtract the two coefficients, I just get 3x. So 7x minus 4x gives me 3x. I cannot combine things that are not like terms though. So I can't combine the 3x with the 10 or the 3x with the 3y because those are not the same variable part. So again, this is where sometimes it gets confusing for when we're going through a section like this. But that is actually the final answer. 3x plus 10 minus 3y. That is the simplified answer. I can't evaluate it anymore because I don't know what x is, I don't know what y is, I don't know what those, they're not telling me what those numbers are. The directions for this again would be something like it says down here, simplify. It would say simplify this problem. And that is what I did. I simplified it. I combined like terms that I could, and that's as far as I can go with that problem. Unless they tell me what x and y are, that's as far as that problem goes. So we'll look at a few examples here together. Again, the directions for these examples say simplify. So I'm going to simplify each of these problems, each of these expressions as best I can. I can't evaluate, I'm not going to find the final answer, but I can combine some of the like terms and make this expression simpler. So for example, in number 1 here, I have 2y plus 18y minus 6y. All of these are like terms. They have the same exact variable part, the y. So in this case, I can add these first two. 2y plus 18y is going to give me 20y. And then 20y minus 6y gives me 14y. So I can combine all those like terms and just get 14y. And again, that's as simple as that gets. I can't combine anything else. I combine all three of those like terms though. 14y is my answer. Going down to number 2 here. 12y squared plus 47x minus 7y squared. Again, when I'm combining like terms, I'm going to look for ones that have the exact same variable part. So right here, y squared and y squared, both those terms have the same variable part. Those are the ones that I'm going to combine. 12y squared and then negative 7y squared. Again, like I've mentioned before, also in class 2 and starting to in this section, when you're looking at a term, the sign in front of it, that's what tells you what you need to do with that particular term. So in this case, there's a subtraction sign in front of the 7y squared. That means when I combine it with other 7y squareds, I got to subtract it. So you could even kind of rewrite this problem as 12y squared minus 7y squared plus 47x. If I kind of rearrange it like that, that tells me that I'm going to subtract these two like terms. The sign in front of a term tells you what you're going to do with that particular term. So in this case, again, because it's subtraction, that tells me I have to subtract that term from the 12y squared. When I combine those, 12 minus 7 just gives me 5, so it's 5y squared plus 47x. And again, I can't combine those anymore. Those are different variables. So I cannot combine the y squared and the x. I can only combine like terms when I'm simplifying a problem like this. Jumping over to number 4 here, same kind of thing. I'm going to try to simplify this problem. There are like terms in this problem that I can combine. They are just the constants. I can combine 4 and then 15. And again, the sign in front of the 15 tells me what I'm going to do or how I'm going to combine it with other constants. I'm going to add it. So it's like 4 plus 15, which gives me 19. And then again, the sign in front of this term here, the subtraction in front of the 12x tells me that has to stay in front of that too and stay with that particular term. So it's 19 minus 12x. I can combine these two terms, and then when I'm done with those, I have to subtract 12x with it, so 19 minus 12x. And the last one I'll go through here is number 5, 7x squared plus 5xz plus 10x squared. Again, here in my like terms, 7x squared and 10x squared, I can combine those, and that gives me 17x squared plus 5xz. So again, in today's lesson, we worked on combining like terms and simplifying a problem, and also talking about what terms, coefficients, constants are. So those are the things we'll need to work on going forward, because we'll use all these things, again, in the next few chapters. So all very important things that we need to know as we go on from today.